My name is Muhammad Basman, and now we'll be presenting on the lab chapter 3, which is regarding a time relay. So mainly here we focus on the ITR and also ADTR. So ITR is known as the inverse time relay, and it have an operating time depending on the magnitude of current, and generally with an inverse characteristics, the operations of time of the relay is smaller as the current gets larger. So this relay have two settings, which is pickup current and also current type, curve type. Sorry, it slow to trip at low current and it faster to trip at high fault currents. And it used to coordinate overload rotations, which may have starting current, uh, which generally this reverse time relay is the most sensitive and slowest to operate. Meanwhile, the DGR is also known as the definite time relay, which is it operate with some intentional time delay and is adjustable. Delay with it, it is adjustable along with the current pickup level. So although these relay are adjustable, their time delays are not necessarily dependent on the current value. So it is mainly used on to coordinate over other definite time or instantaneous protections. So generally, this DTR is less sensitive to prevent operating for load in a rush. So it is faster operating times.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakimi bin Muhammad Murad, and I'm going to present about activity 1, which is resetting ratio of undervoltage or overvoltage time relay. So basically, this is the circuit that will be assembled during this activity. So the component consists from this activity will be 3-phase power supply, acoustic continuity tester, or we can call it as a buzzer, then electronic stop clock. So this is the circuit that will be connected. So this will be connected to the relay, and this will be connected to the buzzer to emit an alarm. So this is the table for operating values while supply voltage increase. So operating voltage will be 360, the release voltage will be 372, and resetting ratio will be 1.03. So for the operating values while supply voltage decrease, the operating voltage will be 401, resetting voltage will be 387, and lastly the resetting ratio will be 0.97. So that's all for activity 1.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Fahmi Zardin with number matrix of AE1800083 from group A1.3. Okay, for this lab chapter, which is the protective relay lab, I will explain to you the activity 2 for this lab chapter, which is time adjustment of under voltage and over voltage time relay. For the connection of the experiment setup is just like the same for activity 1, which is the connection between power supply, relay, voltmeter and buzzer with the timer. Okay, for this activity, we need to adjust the under and over voltage time relay. We maintain the VM for under voltage and over voltage, but the TM was set from 0 to 100, which is 0%, 25%, 50%, 75% and 100%. Then we set the time TM, which is 0 to 100%. After that, we can get the time, which is the recorded time for the operation of the release bus after start the operation. Okay, for according to the collected data, the operational time of the relay for under voltage and over voltage relay is the same or approaching either, as shown in the table here. That's all from me. Thank you.
So for now, I will present on the activity 3, which is regarding the inverse time over current relay. So in this inverse time over current relay, we have here the first item is that the three-phase power supply over here, and then we have CB, which is the circuit breaker, and then we have a transformer, and we have the emitter over here, and then we have a relay, and then the resistive loads, and also we do not forget the buzzer and also the timer. And then the connections is overly like this. Okay, so for the connections on the transformer is primary sides of the transformer is in delta, meanwhile the secondary sides of the transformer in star. And then the load over here, the resistive load is connected in star with settings of R1, R2, and R3 is equal to 7 ohm. And this auxiliary supply of this auxiliary supply will be supplied which is equivalent to 220 volts that connected to relay and circuit breaker. And then after everything is connected, the systems can be started. So once the relay is stripped, the relay over here, once its relay is stripped, so time will be recorded. So this repeats for another R value. So then we will get the results of something like this. Okay. So by the decrements of R, we could see over here that I is also will be decreases. And then for TM is actually a measured trip time, and also the TC is actually a recorded time to trips. So uh, both of these will be increases, which this emphasize that the relationship between the and R and also the time to trips is that whenever the R is decreases, the time will be increases. So this saying that their relationship is inversely proportional. So mainly we have here that TM is a experimental, which is we get the time from the experiment, and so the TC is theoretical, which we calculated it from manually. So the slight distinguishes between these two values is because of probably of internal resistance of equipment that we used in the laboratory, or products error and etc.